Hi, and welcome to this section of the Advanced Calculus 2 tutor. And in this section, we're going to kind of complete our study of sequences and series and convergence limits and things like this. We're going to talk about the ratio and the root test for series convergence. So we're going to have several definitions and theorems here in the beginning. Unfortunately, we have to plow through those, and then we'll get to the problems and show you how to kind of use them. One thing you need to kind of remember is that, there's rarely one way to solve a problem, okay? And so what you're going to see when you get to your test and when you start seeing some of the problems in this section, you might, and I hope that you'll see pretty soon that the light bulb will go off and you'll realize that some of the other methods that we've used in the past can also be used to figure out if these things converge or not. So you might be presented with a problem here, and we might be solving it using the ratio test, or the root test here, and we'll show you how to find out if it converges or not. And then you might be thinking, well, geez, I could have used the integral test on that, or I could have figured out another series and used a comparison test and had that guy proven by another theorem there. So it's just like integration. A lot of times you'll have an integral involving sines and cosines. You can apply one method over here, and you can do this clever substitution over there. There's different ways to solve a problem, okay? So when you're going through this section, try not to pigeonhole yourself into thinking that these problems can only be solved by these methods. It's just that we have to put these methods in your tool bag, so when you're on your test, hopefully one of them will spring into action in your head, okay? So first thing we're going to do is do a couple definitions and quick little theorems and jump into the problems, okay? We've talked about series convergence for the last several hours, and we've talked about what we're trying to do there. We're trying to find out if this infinite series of numbers that we're adding together actually converge to a number, if they actually converge to adding up to a unique number, even though we're adding an infinite number of things together, okay? So that's called series convergence, okay? It's going to be useful to define something here, and I'll show you what that's called, and that's called absolute convergence. And the reason we're going to define that is because it's used in the ratio and the root test theorems that we're going to learn in this section. So the first thing we're going to define is when a series is absolutely convergent. Instead of using the term convergence by itself, you put a little modifier on the front. You say it's absolutely convergent. It's a fancy word. All it means is if you take the absolute value of the terms and then take the series, it's convergent. That's called absolute convergence. So let's go ahead and write it down. We're going to write down several little definitions and theorems here, and then we're going to get to the problems, okay? So we say a series, obviously denoted like this, summation over the terms a sub n, is absolutely, and I'm going to underline it because it's a term, convergent. Okay, that's part of our term. Okay, if the series of absolute values of the terms, and you would write it like this: sum over absolute value of a sub n is convergent. Okay, so it's a lot of words, but it's really not that big of a deal. Basically, you're given a series. Presumably, this series can have positive or negative terms, and we're interested in finding out if this series converges or not when you add up all these terms at a sub n, if it converges to a number. Okay, so we define something, and the reason we're defining it is because we're going to use this in just a minute. We say this series here is called absolutely convergent if the